Okay, guys, are you back?
Yeah, we are back.
Okay. Yes, to just take this discussion forward, I don't know if you are able to. Where is that? Okay, here, right? So we are talking about pandas profiling, correct? Correct. If you just use click on any of these statistics and just let's say Pearson's correlation and click on toggle correlation descriptions. Toggle correlation description. Correct. In case you forget in the examination or if you have any confusion like what is Pearson's correlation, you can just do this. And can you read what is written there? Explanation. He is just explaining when to use Pearson's correlation. For linear relationship and such things, you can use Pearson's correlation. Can I just take a couple of minutes? I don't know if Ajaz has come. If people miss out, then again, right, they'll not be able to follow the rest of the discussion. Right? So I don't know if he's there. Right? When to use Pearson's correlation is clear. Right, clear, right? Right. Let me just click on Spearman's correlation here. He's also saying an additional point. He says basically Spearman's rank correlation. Let me stand here and speak. Is a measure of monotonic correlation between two variables and is therefore better in catching non-linear relationship. So if there is any non-linear relationship and such things that will go undetected when you use Pearson's correlation. So it is better to use Spearman's rank correlation. Here again, the range is always what? -1 and +1. Please keep the range here. Very, very important. It is -1 and +1, indicating total negative correlation, right? 0 indicating no monotonic relationship and 1 indicating total positive relationship. And the next paragraph he is just talking about how to derive this correlation. So just in case you forget this correlation, this is what you need to sort of report. Is this clear, guys? Missing values. I'm just looking at the missing values here. We have got 4, in fact, 5 variables. Here, you should not read this as missing values. It is basically the 100% of the cases are filled. You don't have any missing cases here. That is what it is telling you. Out of a sample size of 150, 150, 150, all the values, the entire data set has 150 records, or it is completely populated. Are you clear with this? Right? Sir, you have to type the second code. I don't know if you have been able to do that, right? Then come to sample. This is just for you to preview. It is just giving you a sample. This is preview. You can't construct any EDA and such things. Take a glimpse of the data set using this sample. Last rows also, it is just giving you last 10 rows. Duplicate records. Most frequently, I don't see any duplicate record rows and such things. Most frequently occurring is sepal length 5.8. Okay, 2.7, fine. Number of duplicates. Okay, there are 2 such records which are duplicated, right? So here it might not make sense, but in the case of employees and such things from the same person, if you have taken records 3 times or 4 times, then we want to duplicate it. Remove the duplicate. We don't want, right? Each case must be unique. So if name, okay, I can understand Preetham and Preetham. His age may be different, so you can have 2 Preethams. But if every value is the same, Preetham, age is 18, working in the same thing, college education is the same, it means that you have duplicated. You don't need such records. You have to remove the duplicate cases. So removing, is that an authentic case or not? I have to again go back to the data set and check once again. Are you clear with this so far? Right? Now I know that there is a lot of information. If I was in your place, tomorrow if somebody asks, can you prepare an EDA report for this data set? Correct? Can you prepare an EDA for this data set? You know, how will I present it? Can I just quickly show? Because from the point of view of examination as well as other things, for a capstone project and such things, if you have to prepare an EDA, let me just come here, right? This is my EDA, right? You can obviously fine tune it how much ever you want. I leave it to you, right? I will just go to pandas profiling. Firstly, correct. I can just right click on this. Okay, I'll have to save this. So there is no way in which I can directly copy this. Okay, share, does it work? Okay, let me just save this in my desktop. So this is what I think it'll save the complete thing. Maybe a screenshot would be better. Okay, it is saving everything. I was hoping that I can just copy paste the one part itself. Like for example, here you can see copy page, copy image. Can you see this? Once I save this, I'm able to copy this image. So if you want a correlation map and such things, just come here, select that. In the PowerPoint presentation, I can just paste this guy here. I think it is coming out well. At best, maybe I can take a screenshot. Copy. Come here and then maybe paste a few selected graphs, whichever are making sense. So for univariate analysis and such things, maybe you can just construct a bar chart. For bivariate analysis, give a scatter plot, and then you can go on to your correlation. I'm just right, whichever is making sense. So this is the first graph. It makes some sense, right? This is basically we can just go to this particular graph. Okay, I think it is forcing me to take a drag or click on the page to select a region. Okay, let me just select this region. And copy. No, not copied well. Save page, select all this frame. There is an easier way of copying each of these graphs. Copy. Yeah, some of these graphs. Yeah, so univariate analysis, histogram and such things you're able to copy, right? This also can be copied, right? So ideally speaking, what all things you should just pay attention to in EDA. One is the missing value percentage if there are, just highlight that. That is your DQ report. Duplicate cases if there are, just highlight that. Univariate analysis in terms of histogram and such things you can copy paste. Next move on to scatter plot that you can do 2 or 3 graphs. Then finally what will you do? You'll be doing your Pearson's correlation. I think that should be good enough. Is that doable, guys? Is this doable? Pandas profiling. Doable. Any concerns, any questions? Please ask me.
Mithun, one concern here.
Yes, yes.
So can we customize the report so that we can get only certain parameters inside the report? Say, for example, if I want only Spearman's correlation, just a Spearman correlation and some PDF, can I customize it like in the Google Colab?
Customize this.
The report itself, the report, complete report.
In a complete report, is it? So you don't want it to display?
Yes.
Pearson's correlation. That's what you're saying, right?
Yes. For just for example, yeah.
Okay. For example, I have not seen anybody being able to go to that extent wherein you're able to customize, but okay, let me see.
It might
Pandas.
make our life easier, right? Yeah.
Sorry.
It might make our life easier if I
Yeah.
get everything in a good report, like.
Yeah, but that outside pandas profiling you can do, not within pandas.
Not
profiling.
within pandas profiling. Okay.
Yeah, outside you can just write your own custom made code wherein we had customized so that you could get just a graph, bivariate analysis graphs, 15,
Okay.
20. Other things are not required, but that has got nothing to do with pandas profiling as such. There's some separate code that we had done to get bivariate analysis.
Okay. Thank you.
So pandas profiling is clear, guys. Pearson's correlation, Spearman's correlation is doable for numeric variables. With this, so far you're clear, everybody. Any questions, please ask. Right. Now, one thing which I would like to say is, I took a small example here because, sometime back I was trying with a different data set, Titanic. And there in Titanic, you have multiple variables. Correct? In multiple variables in Google Colab also, because of space issues and such things, I didn't get it. Right? Now that you have understood the concepts, can you just take 5 minutes to try this on Titanic dataset? Everything is the same, just that you have to load the Titanic dataset from the Seaborn library and generate the same report. Just check if it is working. Titanic, yeah. It is already there in Seaborn. Load underscore dataset, just type Titanic here. Please type Titanic here. Usually we'll have a lot of errors and such things, right? So you can see here, the reason I'm saying this is because this is a rich data set. In the case of Iris data set, what you had? 4 numeric and 1 categorical variables. Here you have multiple variables. See, survived variable is what? Flag variable. Passenger class is again categorical variable. The variable gender is a flag variable. Age is a numeric variable. Siblings and spouse, flag variable. Passengers, number of parents or children. Fare, this is a numeric variable. Embarked, right? Single, if I'm right, embarked SC. What is this XC? Let us do a help here. So this type help of Titanic. You will get a variable explanation for this. Yes, I'll do. Useful. Okay, let's do one thing. This is a competition. Just give me 1 second. Data set.
I think you're talking about SABSP.
I'm talking about this variable. Which is that? That is siblings or spouse.
Hmm.
Sib and SP is nothing but siblings and spouse. I'm looking for fare is there, embarked is there. Passenger class, gender, age, siblings or spouse. This is parents and children. This is fine. Fare is fine. Embarked. This variable, the variable embarked.
Okay.
Okay, usually in Kaggle, they'll give the description.
Looks like where the traveler boarded from
Oh, is it okay? Okay, okay.
or
Okay.
mounted from.
Embarked. Okay, okay. Like Southampton, something like that. I think
Correct.
so. It could be like that. Okay, and passenger class. Who is he? Is he a man or a woman? Adult male, true. Deck, embark, town, so on and so forth. Like for example, you can see here, guys. Can you see this, everybody? First person embarked is S. They've given the letter S, and here it is Southampton. C basically is Cherbourg, right? I hope I'm pronouncing it properly. Is a person alive or dead? Alone, false, or has he embarked with family? Correct. So can we try preparing a quick profile report for this data set? Considering that we have mixed data type. You have both categorical variables as well as numeric variables here, right? Quite a few categorical variables and quite a few numeric variables. Right, same thing. They load the data set and quickly run a pandas profiling. I will just say Titanic underscore. Okay, you can see here some of the things, guys. See, now it gives alerts. Okay, this is a previous alert. Okay. I will close off the previous stuff so that I get fresh. This is Titanic. I'm just changing the name to Titanic everywhere. Load the data set Titanic and the report and all, you can just change it to Titanic. Crash rate after some time because the large data set. I know this. With Titanic, it's slightly difficult. 93% is a maximum it will process. After that, it doesn't process usually.
It is crashing for that.
Yes, 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 yes. Maximum 93. Okay, 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 okay. Okay, but I hope you got a feel of this, guys, right? How pandas profiling works for other data sets. Okay, shall we move on to the next topic? Shall we please move on to the next topic? Okay, if you want, you can say just save this, give it a name as automate EDI using pandas profiling package. You can just save this. Guys online, were you able to follow this, guys? If there are no questions, shall I make a move on?
We are good, yes.
Okay, I'll just close this pandas profiling. I'll just close this. Just to avoid confusion, I'll close everything. I don't need. Let me just come back.
The only comment that I had, though you suggested like that we downgrade to the older version, sometimes like now the upgrades happen to cover for the security issues or performance issues, right?
Yes, you're right.
Mithun?
Yes, yes, yes. This is not with every package I'm saying. Only there are specific packages which are very cranky, like pandas profiling or TensorFlow and such things. Very rare. It will not happen always. But some specific areas wherein you might have to downgrade. Only here and there you may face stray cases. That's when it happens. Not everywhere.
Sure. Okay.
Okay. Yes, so far what we have done is basically so far in the last 1.5 days, we looked at fluid, all the summary statistics. Today we looked at measures of dispersion, correlation we have seen, correct? Now slightly shall I just go on to the next topic, right? This next topic is what is called as inferential statistics. From descriptive statistics, mean, median, mode, count, median, right? Graphs. We've seen quite a few graphs last class, pie chart, bar chart, right? Today also we've seen quite a few charts, right? Missing values, all this. Now we are talking about inferential statistics. Inferential statistics. Okay. Here, there are specific business problems that we are trying to solve. Okay. Specific business problems. Let me just highlight some of these things. I'll close all the unwanted things. I'll just close. Okay, just give me one moment so that I can just open up this relevant file here. ABC D drive. Guys, can you see this Excel sheet, guys? Can you see this Excel sheet? Can you see this Excel sheet, guys? Everybody?
Yes, we can.
Yes, you can.
Okay. See, there are specific business problems that you may come up with, right? For example, what are the business problems that you may usually come up with? Let's go back to, I was just talking about campaign analytics, correct? When we talk about fluid, right? So if I'm a campaign manager, I would like to know which specific areas is the response rate high in, correct? Kormangla, I'm just giving the example of Kormangla. There it was different places like Southampton, blah, 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 different, districts. Is the response rate very high in area A or is it very high in area B? If it is extremely high in specific pockets of UK, I can go and send campaigns there. But how do you establish whether there is a high response rate or not? And the question is there any statistical evidence for you to believe that in certain pockets of Bangalore or UK, there is high incidence of response rate? Am I making sense? Certain pockets, like for example, if across Bangalore, I noticed that, okay, Jayanagar, Kormangla, and let us say HSR layout and Indranagar, these are the 4 areas wherein the response rate is 8%. In all the other areas, the response rate is barely 2%. It makes sense for me to go and campaign only in these areas, right? All those areas wherein the response rate is lesser, I will not waste my time, money, energy, and efforts there. So we are moving into what is called as inferential statistics. First step, we have looked at EDA and such things. We have put a full stop. Now we are talking about what is called as hypothesis testing. Hypothesis, the word hypothesis, do you all understand? Any idea what is hypothesis? What exactly do we mean by hypothesis? Any idea?
So we make a statement?
Yeah. Yes, please.
No, meaning like hypothesis assumption made as a statement.
Yeah, it can be an assumption, correct? It can be an assumption or a business idea or an empirical idea that you have. Correct. I've noticed that in the entire country, basically Maharashtra is the place wherein COVID incidents were the highest. It was standing out from the rest of the country, right? Is there any strong data-driven mechanism through which I can establish, yes, Maharashtra is the one place wherein the number of incidents of COVID and such things were tremendously high as compared to the other places. Correct? I believe that throughout the throughout the year, my sales performance was basically at 6%. Just that in the month of December, it rose to 16%. So that is a standout month. Male response rate and female response rate to campaigns, is it the same or not? Is it the same or not? Usually when you go to most of these market research, there is a metric which they track, which is called a CSS, Customer Satisfaction Survey. Customer satisfaction. There is another form which is called as NPS. Have you heard of NPS? Has anybody heard of NPS? NPS stands for Net Promoter Score. Net Promoter Score, NPS. It's a universally accepted. It's not my saying. It's a universally accepted metric to understand whether the customers are satisfied with your service or not. On a scale of 1 to 10, if your NPS is greater than or close to 10, it means that you're doing well. On the other hand, if the NPS goes down, it means that Samsung or HP or Dell or any of these things, basically they're doing badly. So month over month, they track customer satisfaction. I'm making a call to, to a person. I'm asking her to repair my laptop and such things. These are the XYZ issues. Or let us say I'm facing a lot of banking issues with my card. It is blocked or it is lost. What is the kind of customers? What is the kind of service that I'm getting from ICICI Bank? At the end of the day, they ask. I give a rating saying it is high, medium, or low. Customer satisfaction. What are the factors? Is it influenced by? I want to find this out. Because once I know that these are the 5 factors which are related with customer satisfaction, I can only focus on that. Are you able to understand? So for this, we do what is called as hypothesis testing, comparing between 2 groups, finding out relationship between 2 variables, seeing whether the sales is as per my benchmark, or is it less or is it more. Attrition rate, you have heard of, everybody? Attrition. People keep leaving IT companies. There's a lot of pressure and such things. Universally, I'm just giving an example. Across the industry, I'm saying for the last quarter, the attrition rate was 8%. I'm just giving some rough number. I want to know whether in my organization, let's say I'm working for Fidelity, whether the attrition rate is 8% or it is less than 8%. If it is less than 8%, I'm doing a splendid job. If it is exactly 8% or close to 8%, I'm doing a job as per industry standards. If it is more than this, then it means that I have something to worry about. So to test any of these problems, may it be attrition, may it be incidents of COVID cases, may it be other metric, customer satisfaction and such things, there are certain statistical tests that we use, which I want to talk about. Primarily, there are 5 important statistical tests that I'll be talking about. First one is what is called as chi-square test. Chi-square test. I'll tell you when to use it. Second one is what is called as t-test. Within t-test, you don't have 1, but 3 different forms of t-test. What is called as one sample t-test. Second one is A/B testing. And the third one is paired samples t-test. The next one is what is called as ANOVA or analysis of variance. Within ANOVA, there are at least 2 different forms of ANOVA. So totally, there are at least 6 tests which I want you to be good at by the end of today. So all these things are not part of your EDA and such things. These things are part of what is called as inferential statistics. Statistical tests, sorry. Chi-square test. So there are multiple forms of chi-square test. One form of chi-square test is chi-square independence of attributes. By definition, it is for categorical variables, which means that the data can be non-normal. So we'll see this, right? So one of the first tests that I want to introduce today, one of the first tests is to check the relationship between variables. We want to check whether 2 variables are related or unrelated. Simple problem. Correct? Right? But just now, before breaking for tea, did we not speak about relationship? I spoke about correlation, then why am I again using chi-square? The correlation itself, we spoke about Pearson's as well as Spearman's rank correlation. Then why am I again confusing you by talking about chi-square test? Okay, that is spurious correlation. That's again correlation. When do I use chi-square? When do I not use chi-square? Right? I'll be telling you both. Right? I want to tell you both. Right? So for any business problem wherein we are checking the relationship and such things, we can use chi-square test. Chi-square test is used to check whether the two variables are related or unrelated. Then you may ask me, sir, what is the difference between chi-square test and correlation? Biggest difference between chi-square test and correlation is correlation as a test you use when you have two scale variables or numeric variables. Even if one of the variables is categorical, it is better not to use your correlation at all. Then what should I use when I've got two categorical variables? When you have got two categorical variables and you want to check whether these two categorical variables are associated or not associated, you have to use chi-square test. I have to use what is called as chi-square test to check whether the two variables are related or not. Gender, right? What is it? Is it a scale variable? It's a categorical variable. And whether a person responds to my campaign. Response variable is what? Binary, yes or no. Either you respond or no. It is not a scale variable. Both these variables are what? Categorical variables. When these two variables that we are talking about are inherently categorical, we don't have any business to use correlation. Straight away use chi-square test. What is the difference between chi-square test and correlation? Two differences. Chi-square test comes into picture for categorical variables. Chi-square test does not talk about strength or direction of the relationship. It does not tell you, sir, these two variables are strongly related or weakly related. Chi-square is very silent. Pearson's correlation talks about this. Pearson's correlation comes into picture when you've got two numeric variables, and Pearson's correlation comes into picture when you want to address the question of strength as well as direction. In the case of gender and response, I can't say as gender increases, response rate comes down. How can gender increase? It's not meaningless, right? Therefore, we don't talk in terms of strength and direction. Is there a relationship or not? To that extent, I can comment. Okay, so what I will do is with this background, what I will do is please. Direction isn't like this, like. One second. Gender hates the campaign or gender likes. And whether they have responded to a campaign or not. But I know a positive response or negative. Okay, guys, online, can we get started?
Yes, sir.
So let me just show you the problem statement first before I begin. Correct? I hope you can see the what happened to this. Correct? So how to approach this problem? Firstly, we'll have to do cross tabulation. Correct? The cross tabulation, right? What is this cross tabulation? It's a simple technique which is used to examine the relationship between two categorical variables. Just when you have two categorical variables and you want to find out relationship, two categorical, use a cross tabulation, correct? Possibly controlling for additional layering variables. It offers tests of independence and measures of association and agreement for nominal and ordinal data. Okay, so this is the background. Here specifically, what are we interested in? What is the problem statement? In order to determine the customer satisfaction rate. So customer satisfaction and such things. What kind of a variable is customer satisfaction? Usually it will not be scale. It will be in the form of ranking, low customer satisfaction, medium or high. There are three groups. A retail company conducted survey of 582 customers. 582 customers, they have basically conducted a survey at 4 different store locations. Okay. From the survey results, you found out that the quality of the customer service was the most important factor to a customer's overall satisfaction. Quality and what? Satisfaction. Given this information, you want to test whether each of the store locations provides the similar or adequate level of customer service. So if I have got 4 locations, basically, let us say Jayanagar, Kormangla, HSR, and let's say which other area? Some Indranagar. In 4 of these areas, I've got 4 locations. Question is basically each of these 4 stores, are they providing the same satisfaction level or different? Is the rating the same or less? If in Kormangla I find that people have rated customer satisfaction is very low, what does it mean? It means that I have to go back and check why is it that people in Kormangla, they're unhappy about the customer satisfaction. Is this clear? Can I show the data set? Let me just show you the data set. How does the data set look like? Are you able to see this, guys? Are you able to see this? Overall satisfaction. This is one of the variables that I'm interested in. And store ID. Can you see these 2 variables? Store ID and overall satisfaction. This is the data set that we have to work on, correct? So store location, what kind of a variable is store? I'm just going to apply a simple filter here. See here, how many stores are there? 1, 2, 3, 4. Correct? With these 4, what kind of a variable is it?
Categorical.
Definitely it is categorical, right? Look at the variable overall here. What is it? Customer satisfaction, overall satisfaction. Some people have given neutral, somewhat negative, somewhat positive, strongly negative, and strongly positive. Now, can I run a pandas profiling package and say, boss, correlation is very high or low? What is there? It may give you some output, but it is not sensible. Why is it not sensible? For the simple reason that I told you, Pearson's correlation and such things are given by pandas profiling. There we did not do any chi-square test, nothing we did. That chapter is over. Just one heat map will give you beautifully and the job is done. Correlation is high or low. That's what we can say. Here, fundamentally, you have to recognize that the nature of the variables itself is that it is a categorical variable. And when the nature of the variables is categorical variable, please don't use correlation. What is the first thing that should come to your mind? 2 categorical variables, you should use chi-square test. That's why, sir, when you are saying, when I have got different products, let's say I've got 5 different products and you used another variable, right? I want to find out whether people respond to people buy this product or not. Product is a categorical variable. Second variable that you have is also categorical. Their correlation is not sensible. Use chi-square test. For categorical variables, chi-square. Numeric variables, use correlation. Doable, guys, right? So is this problem clear? Why we are using chi-square? Is that clear? Is this clear? In LMS, I think Ajin would have shared this data set. Can you please go to LMS and check whether this data set called a satisfaction data set is there with you or not? Is not there? Ajin? Have you uploaded this data?
It's there as a day 2. day 2 file.
Put it.
There are a bunch of files available.
Yeah, sure. In day 2, he says he's uploaded. Can you please check this, everybody? Day 2 LMS. Right now, here you don't need to worry about Google Colab. We'll come to Jupyter Notebook itself. Right now onwards, we can work on Jupyter Notebook itself. We don't have any problem. Right, we can just come to Jupyter Notebook and start working. Right, so can I close this file? Right, do you need some time to open up Jupyter? I don't know if it is already open or closed. Right, I'm just writing the heading, and please feel free to make your own notes in the page itself so that it's very easy for you to recognize it. Right, otherwise it will become like a big chow chow bath. Right, at the end, chi-square is there, correlation is there, missing values, duplicate cases. What is what you'll not understand. Right, so please chi-square test for relationship. Shall we begin, guys, everybody? Just give me 1 second. Everybody's ready with the Jupyter Notebook, guys. If you're ready, we can get started.
Yes, Mithun.
Right? Okay, I'll just keep the focus on Jupyter Notebook. Azaz, sir, sir, your Jupyter. So first thing is basically the existing libraries of Pandas, NumPy, and Pandas profiling, what we were working on so far, is not sufficient for me to do statistical hypothesis testing. It is not sufficient. So I need a separate library. So first thing what we need to do is basically install a code as SciPy. Right? Can you see this? It's a bit scary. Don't worry about this. It's just from scipy.stats, we will be importing chi-square. Right? It is pronounced as chi2 here underscore contingency. Let me just import this library. scipy.stats. This will help you with all the statistical hypothesis testing and such things. scipy.stats. If you want, I'll just increase the font size so that it is easy for you to visualize and see this. I'm just importing this. Shall we break at 1:15 for lunch? Otherwise, we'll not get lunch there. Right? At 1:15, we'll go. Maybe another 5-10 minutes, maybe we can reach there. I think we'll have some lunch there. After 1:30, it's a bit difficult. Nothing, everything will be empty. Right? Okay, we have done this so far. Importing is done. Great. The next stage is what? The next stage is basically, right, I need to import the file, right? So how do I import this? Right, I need pandas library, right? My old friend read underscore CSV will be helpful here. Okay, so I am just going to say pd.read underscore dot CSV. See here, pd.read underscore CSV. Within double quotes, I'm specifying the location of the file. The name of the file is satisfaction.csv. It is a comma separated file, and therefore the separator will be a comma file. Separator will be comma within quotes. Done. So far I've just done one thing, which is to import the file. I've not done anything else. Now this is just optional thing, right? But it is good if you do it. Wherein with this df, I'm just taking a subset. I'm subsetting the variables as a list. Can you see here? This bracket should tell you that I'm looking at only 3 variables, because there are 10-15 variables. You'll get confused. So I don't want to confuse you. Let me just focus on 3 variables. In fact, we don't even need 3. 2 are sufficient actually. Right? Chi-square is a bivariate test of association. So I'm just subsetting these 3 variables and creating a file which is called as df. When you have more than one variable, you have to pass it as a list. This is a list of variables. Done so far, right? So we have copied the data set. We have created a file which is called as df. All right. Let me just visualize the data set by using the head function. Not bad. The data set is appearing. These are the three variables: service variable, store, and contact. In fact, I could have copied only two variables, but I've just copied three. Okay. Now, first thing is basically to do a cross tabulation. Right? We are doing a cross tabulation, right? We all know what's a cross tabulation, right? Everybody, we have used cross tabulation, right? When you have two categorical variables, just a simple cross tabulation, right? In the first variable, in the first argument, what I'm using is basically I'm using store data, store variable. So df open bracket within quote you can pass the string store comma df service margins is equal to true. That will give you the percentage. I'm storing this as an object which is called as cross tab. So I'm doing nothing much here. I'm taking a simple cross tabulation between two categorical variables.
Can you show the code 2 lines in above?
Yes, yes. Any problem, sir?
Okay.
Any problem, sir? Any problem? Okay. Go.
Can you please scroll down?
Can you scroll down?
So can you please show the crosstab code? Code for crosstab.
I posted it. Okay, yes, posted.
Is this done, guys? Everybody?
Yes.
Yes, I'm just copying this code for one person. Okay, so that in case I'll just paste this so that it's a lot easier. Sir, I've just pasted this, sir. And then you can just come to cross tabulation here. Okay, so we have stored the cross tabulation result here. Next is basically let us just show the column proportion. See what we are doing here. Oh, sorry. PD.crosstab. Instead of margins is equal to true, you can just say normalize is equal to columns. Right? Earlier code will just give you the plain numbers, correct? Are you able to see this? It is just giving you the numbers. Now what I'm saying, same code, you can just copy paste the same code, but you can just say normalize is equal to columns here, which means basically you'll get the column proportions. You will be able to get the column proportions like this. Right? Normalize is equal to columns. Why do I say column proportion? Just take a look at this, please. Can you see the column? Is this 24%? 24 plus 21 is how much? 34, 44, 24, 34, 44, 45. 45 plus 26 is 55, 65, 71. 71 plus 28 is roughly around 100%. I'm also, if you take into consideration this, so each of these percentages that you're seeing is based on the column proportion. It will add up to 100%. Is this clear, guys? After this, we can take a break, guys. We'll have to run, right? We can move for lunch and come back. It's 1:20. Ajin, can we come back by 2:20?
Sure, sir. Done.
Okay. I think they'll give some time to participants also to copy this code.
Okay, sir.
Guys, can we be back by 2:20, guys? Is this okay? 2:20, all of you. Ganesh, is this okay?
Oh, yeah, sure. Yeah.
It's okay, sir. Yeah.
Anand? Okay, thanks.
Yeah, thanks.